Hi, I'm Isaac. Today I will show you what a logarithm is and how to use them to solve questions. A logarithm is an expression that tells you how many times you multiply a number by itself to get another number. It does this by using its two components, the base, which is this small number here, and the argument, which is to the right of it. So if this logarithm has a base of 2 and an argument of 8, it is saying how many times do we multiply 2 by itself, right? So 2 times 2 times 2 to get 8. And we will do that by doing 2 times 2 times 2. The number of times we multiply 2 by itself is 3. So that's why the value of log base 2 of 8 is 3. If I have a logarithm with, let's say, log base 2 of 16, this is saying how many times do you multiply 2 by itself to get 16. And you can write that out as 2 times 2, which is 4. You can do that again, and we'll get 8. And 8 times 2, one more time, will give you 16. The number of times we did that was 4 times. So that's why this logarithm is equal to 4. This is the core concept of a logarithm. One of the main uses of logarithms is to solve an equation like this, which we call an exponential equation. A number like this that you see over here is an exponential number, with the number at the bottom called a base and the one at the top called a power. To solve this, our goal is to obtain the w as the subject of the equation. So w equals to something, but it's stuck up there in the power. So we have to get rid of the exponential base 5. Now, an exponential base is the exact opposite to a log base, as shown here. In the very same way that plus 3 is the opposite of minus 3, and times 10 is the opposite of divide 10, this exponential base 5, right, so 5 to the power of something, is the opposite of log base 5 of something. In the Western world, we usually apply a log base 5 to both sides, so that the exponential base 5 and the log base 5 will cancel each other out. You can also think of it as moving this exponential base 5 to the other side of the equal sign, where it will transform into log base 5. Now once we do this, the w minus 1 would drop down on its own, and on the other side, we would have log base 5 with the argument of 12. So whatever that was on the right hand side will become the argument of the new log that is there. Then you can solve like usual. So here we get w equals to log base 5 of 12 plus 1. And that's the final answer. That's the relationship between exponential numbers and logarithms. Their bases are the opposites of each other. Let's try another example. In this one, we need to get access to the 2x minus 3, because that's where x is located. So we need to get rid of the log base of 6 that is here on the outside. The opposite of log base 6 is an exponential base 6. So when we move the log base 6 to the right hand side, we get exponential base 6 with a power of 1 over 2. So in this case, we would have 2x minus 3 equals to, this thing moves over to become exponential base 6 power 1 over 2. Then we solve by adding 3 to the right hand side, moving the minus 3. So it's 6 power 1 over 2 plus 3. And then finally, we can divide by 2 This is a 2 times x. So x is equal to all of that divided by 2. If you want, you can write 6 power 1 over 2 as the square root of 6. So for example, something like this would be fine as well. Root 6 plus 3 over 2. Try this last example to see if you can solve it yourself. Feel free to pause the video. For those of you who managed to get it, congratulations. The solution is to move this exponential base of 3 to the right-hand side of the equal sign. When we do this, the x over 2 minus 1 from the power drops down, and that's equal to log base 3 of 10. The exponential base of 3 has transformed into a log base of 3. From there, we are going to move minus 1. X over 2 is equal to log base 3 of 10 plus 1. And then we're going to move the division of 2 over. So x is equal to this whole thing multiplied by 2. You can put this into your calculator to get a decimal value. I get roughly 6.19. And this would be the answer here. A common question is whether we leave our answers in this form or whether we put it to decimals. Now, normally we leave our answers in exact form, unless the question says to round to 1 or 2 or 3 decimal places. In this case, there's no specification, so either one should be fine. So that's how logarithms work and how we use them to solve basic equations. If you found this video from my Instagram, thank you for your amazing support. And if you found this useful, please share this with your friends so that they can also learn. That's all from me. Thank you very much for watching.